Hello everyone. So in today's class, as you can see, we're still going to be continuing going over kind of the review session, over all the coding bat stuff. So when we kind of go over this kind of stuff, then we can, I hope that you guys can kind of learn how to do this yourself. Again, I know it's a hard process, so just kind of take a minute to kind of try and remember what we went over before this, um, and try to remember like the exact steps that we need to take. Alright, so hopefully you guys can remember at least a little bit. Again, I don't expect you to fully remember all this stuff or anything like that, right? Because we've only been doing this for like 5 classes, so I know it's a learning process. It's kind of learning from experience and also learn from like just kind of watching over these classes. So I perfectly understand if you don't get it the first time. Um, so as we kind of move on through these classes, I hope this kind of gets easier for you to understand because, you know, like repetition usually makes it so then it's always easier for people to kind of understand the different topics, I guess. So without further ado, I guess we can start. We can get started on some of the questions that we're going to be doing today. So why don't we go ahead and head over to CodingBat. So let's log in first, and we can go to Python. So we went over a string 2 problem last week, which was XYZ there. It was pretty simple in the end. So if you if you want to learn how to solve this and you didn't watch last class, then I suggest you go ahead and watch that. So we're going to be going on to list 2. So we're going to take this question, has 22, okay, and what I want you guys to do is read the instructions again and go over the test cases. Um, so I'll give you guys about 2 minutes to do that, and then I can get started. guys were able to get a good idea of what's going on here. So when we go ahead and we look at this, so we're given define has 22, and we are given an array of integers. Let me check the name that we are given. It is called nums. Alright, so we see given an array of integers, return true if the array contains a 2 next to a 2 somewhere. Right, so we have a couple things that we need to go over here. So first of all, when we look at this question, we need to identify exactly what we're trying to solve and what we are given. So it's pretty obvious that what we're given is this array of integers, right? So we're not given the length of it. We're not given like some specifications other than the fact that they are all integers. So we can kind of picture what these possibilities might be. You know, it could be 16273. It could be 11111, right? There's nothing against the fact that it could be repeating either, right? So when we think about this and we go like, oh, okay, well, we know that it has to be an array of integers, right? And we also know that we want to look for a 2 next to a 2. How are we going to find this? So we need to think, alright, well, in order for us to find a 2 next to a 2, that would mean that we would have to find the first 2. So we need to think in the pseudocode, when we write it, we need to see check if the array has a 2. Right? So that would be our first condition. And after we go through this condition, we can think about, alright, well, say that we find a 2, right? Say we are given the array 1, 2, 3, 4, 5, right? If we find a 2, what do we do with it? Well, it says a 2 next to a 2. Well, what exactly does this mean? So that means that it can come in the place of this 1 over here, meaning that it would be 2, 2, 3, 4, 5, or it could come in the place of the 3. So it'd be 1, 2, 2, 4, 5. So these two cases would work, right? So we put a no next to this, we put a yes here, and we put a yes here, right? So we can see these two cases work. We have 2, 2, and we have 2, 2, right? But now we need to think, alright, how do we put this into words? How do we put this into code, right? If we were to think about it, if we check over it, we go like, check if the array has a 2, right? So then we need to check, is there a 2 located next to that 2? Alright, and when we think about it, we go like, alright, well, that's kind of interesting how it works, alright? Is there a 2 located next to that 2 that we found? Well, then that brings about another case. Well, if we were to go ahead and say this is not true, right? So, false case, right? Then do we just return false? No, we cannot. And the reason for that is because there is a possible case in which we find it, say, 2, 3, 1, 2, 2. Now, this first 2 that we find over here, which is most likely going to be the first 2 that you guys would find as well if we were kind of just scanning through this list, does not, in fact, have a 2 next to it. It has only a 3 and a blank, right, or null, because this is the first term. So we can't just return false here. So instead we need to delete this, and we need to say, alright, well, there's a false case. Well, there's also a true case. Can we return true if it is true? So we think about it. Alright, well, if we return true when it's true, and this question is only asking return true if the array contains a 2 next to a 2, meaning that there could be multiple, there could be none, and there could be 1. That means that we can, in fact, return true when we find a 2 located next to a 2. So we just go ahead and we return true. Now, we've got the working case down, right? We know, alright, well, if this in fact works, then that means that when we go ahead and we are to write out this code, we need to make sure that we have a case in which, say, it's like this over here, right? There is no 2 next to 2, right? And then we need to think about this case over here, right? So we can see that in this case it works perfectly fine because it has this 2 right here located next to this 2. So it goes ahead and returns true, right? But if there is a 2 over here and we see that there is no 2 next to it, there's only a 1 and a 3, then it tells us to go ahead and return false, right? As in these examples over here. Now, how do we go and return false, right? We can't just go ahead and go like, well, if there's no 2 next to the first 2 that we find, then we return false, because we already found this case that proves that statement to be wrong. So instead, what we do is we skip over the else statement entirely, alright, and we just go ahead and return false as the last statement. And you may be wondering, well, how exactly does this work? Why can't we just go ahead and return false without going through any conditions? Well, the interesting thing that's happening over here is, in fact, this false return over here is actually working like a base case in which there is no 2 located next to a 2, right? So no longer are we checking condition, right? But we're just waiting for this loop of checking to end. And when it ends, and we know that there is no case that returns true, then it must be false, right? So this is making sure that we cover all cases. And in some programs where you go ahead and you program this and you write an if statement that says else return false, right? However, sometimes it never actually breaks into the statement, right? Then we have a no return when we call this function over here. And that is another error that you can get when you go ahead and you program. So I want to make sure you guys really understand this, so I'll give you guys a couple minutes to just kind of go over this. And then after you go over this and you make sure you understand the logic that's going on here and how we were able to go through every case, then I want you guys to go ahead and try and turn this into actual programming code, right? Python. So I'll give you guys a couple minutes to go through this, and then I'll come back. hopefully you're able to go ahead and kind of understand the code that I had over here. So it, or not the code, the pseudocode rather. So what's happening over here is we are going to turn this into real code. So when we think about it, first thing that we got to do is we got to remove all this extra stuff, right? All the cases that we went over. Now, if I were to actually do this myself, I would prefer to write this down somewhere and maybe copy it over to another document. But in this case, I want you guys to kind of see both, so I'm just going to be doing it a couple lines down, right? So the first thing that we need to do is we need to check if the array has a 2 in it. So there's two ways in which we can go about this. So the first way is going to be using a method called find. And find is, it'll kind of just look like that. And it's fairly, it explains itself in its name. It will find whatever you put in this parentheses over here. So if I put a 2 here, it will find the 2 inside the array. Right? Now, for the case of this, I'm going to go ahead and I'm going to kind of write the code behind what's going on behind find, because many times it's a lot easier to kind of understand from the very basics from the very start. So what we're going to do is, in order to find if a certain character is located inside an array, we need to think about how we can check every single element in the array. And checking every single element sounds awfully close to just traversing it, or going through each element, right? It's practically the same thing. So what we're going to do is we're just going to write for I in. So what comes here can make your life a lot easier, a lot harder in some cases. So there's two ways in which you can write a for loop. First way you can write it is for I in range, blah blah blah, right? Second way, whoops, right here. The second way is we can just go ahead and go write for I in blah blah blah. Now, what do these two mean? Well, in this one over here, we gotta think, alright, for I in range, blah blah blah. We are actually going to be going ahead and going through the length that is given over here, because when you write this, this has to be a numerical value. Now, if this is a string or an array, then we can just go ahead and use the len function, and this will go ahead and it will return the length for us, in which we can also iterate using in range. So what this will do is it'll go 0 to length blah blah blah, right? That's a O. 0 to length blah blah blah, right? And you can call whatever number it's on by just using I. Now this is different because in this one, if this we're just going to consider this as a string. What's going to be happening over here is it's not going to be iterating through a number, but rather iterating through each one of these characters over here. So I at any point in time can be equal to W, E, Q, F, U, B, Q, W, E, F. Right? It will go through each of these characters and it will call it. Right? So that's kind of how the two different types of, I guess, iterating using a for loop would work. Right? Now, I'm going to explain why we're going to be using in range. Right? And it might be simpler. You go like, hey, why don't we just go ahead and just use this simpler one right here? Because it'll give us the character. So instead of having to call it at the index, we can just go ahead and we can directly compare I to 2, right? And see if they're matching. Now, this question is different because we are not asking, is 2 in this list? No, what we are asking is 2 located next to another 2 in this list? So if we are to find the most efficient way for this, in order for us to find the original 2 and easily be able to locate the second 2, we need to know the exact position inside of this array. So we are going to need the index. And the only way to find the index, well, without calling an extra function unneededly, is going ahead and using for I in range length of nums. So we're going to go ahead and we're going to write for I in range len of nums. Right? So in this case, we know I is equal to all these numbers all the way up to the length of nums, right? Minus 1. And then we need to think, alright, how can we use this to our advantage that now that we know exactly what numbers I can possibly be? Alright, well, our main goal here is to find the first two. So what are we going to do? We're going to go ahead and try and find the first two. So be careful to make sure you don't, when you write the if statement, write I is equal to 2, right? This is wrong because this is the index I. Rather, we want to write nums at index I is equal to 2. So we have this over here, and we kind of see, alright, well, nums I, is that equal to 2 or not? We check every single one in there. Now, if we are to encounter at an index I that it is equal to 2, we need to go through a couple of safe checks. Now, what do I mean by safe checks? Well, when we look at any array, we have two special numbers, or special indexes. We have a start index, middle, and end. Well, which one's a special one? We have 3 over here, right? Well, we can think about it. We can go, alright, well, middle's not exactly an index, right? But start is always going to be at index 0, and end is always going to be at index len minus 1, right? No matter what is going to happen. Middle can be length of, it can be length of 0 all the way to a bajillion, right? Doesn't matter, because these two are the start one, are the special ones. Now, why are they special? Well, for a middle one, right? Say we have a middle term over here. There is always going to be a term to the left, and there's always going to be a term to the right. Now, a start one is only going to have a term to the right, and the end one is only going to have a term to the left. Right? So we need to consider this, and these are the two special cases that we need to go over. So if nums I is equal to 2, right, then we need to go ahead and check if if I is not equal to 0, right, then we can go ahead and check if, actually, when we think about this, we go, if I is not equal to 0, so that means that if it is not the start, right, not start, right, then we need to think about, alright, well, start only has a term to the right, which means that it doesn't have a term to the left. So that means that we can go ahead and we can check the term to the left. So nums I minus 1, right, so let's write if statement, if nums I minus 1 is equal to 2. Then we can go ahead and return true. Now, why does this work? It seems that we only went over one of the cases, if it is start, right? But upon eliminating start, we make sure that every single one of these terms has a term to the left. Or we make sure that nums I minus 1 actually exists, right? It might seem kind of funny. Oh, does this term exist, right? Why is this so important if we know if this term exists or not? Well, if we go ahead and we try and check this and this term doesn't in fact exist, then what happens is we just get an error. So we need to make sure that we bypass that error. We can go ahead, we can do that same thing, except if it is the end term. Right? And when we check over, is it the end term? then we know that every single term will have a term to its right. So if nums I plus 1 is equal to 2, then we can return true. And just like that, we've covered if there is a term to its left and is there a term to its right. So we go ahead and we go like, alright, well, we think we got it, right? So we can't forget this false statement that we have to put over here. So after our loops through all of it, we just want to go ahead and write a return false. So we can go ahead, delete all this code, all this extra stuff, and let's run it. Why does this not work? Well, turns out when we were going ahead and we were thinking about it, it didn't actually, we didn't go ahead and actually delete everything, right? So we need to make sure that we know exactly what's going on so we can easily identify those errors. And we can see, oh, yay, we got these cases all correct. Alright, how can we simplify this further? Well, if we think about it, when we go ahead and we check off all these terms, right? We're given 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And we go through for I in range, meaning that there's these indexes 0, 1, 2, 3, 4, 5, 6, 7, 8. What's actually happening is we are always going from left to right, meaning that this check over here of checking if there's, or this check over here, checking if there's a term to the left, is actually going to be wrong. Or not wrong, but redundant. Because there's never going to be a time in which we have not checked a case in which, say, 2 is, this 2 over here is equal to this 1, because we've already covered over this 1. Right? So essentially what's happening is when we go over it, we can go ahead and delete this. Right? We delete that index. We check this one. All we have to do is check to the right. So we can go ahead and we can actually delete this part right here. And as we can see, we get all the cases right. So simplifying from this case on is going to be just kind of nitty-gritty stuff. Other kind of stuff that you just want to use in case you want to make it look nicer. I'm not going to worry about that. You probably won't need to worry about that either, unless it's something like, oh, you need to fit all this code in one line or something like that. But that's all just for the visual aspects pretty much. As long as it runs smoothly, gets all the cases right, doesn't do it too slowly, then you should be good, right? So that's kind of how the problem-solving process of this would go about. Hopefully you guys can understand this. So I'll give you a little to kind of make sure you understand this. And in the meantime, while you want to go over this yourself, I'm going to go over one of the questions, in fact, one of you guys had. So a couple weeks ago, we went over warm-up 1 right here, and sum double. So in sum double, we're given two integer values. We return their sum unless the two values are the same. Then we return double their sum, right? So what's happening here is we have this fancy code over here. We have it all working, so we're good here, and we have their solution here. So the question was, in this line over here, why is it multiplied by 2, and why is it, in our case, we used addition, right? Plus 2. So what's actually happening over here is the two code bits that we kind of used weren't exactly the same. So it's important to understand exactly what each term means, because we can have sum in both of these kind of code bits, but they can mean different things, right? So at least in my implementation of it, what happens over here is I use this fancy statement over here. Return a times 4 if a is equal to b, else return a plus b. So there's two things that's going on. First of all, are a and b the same? If they are not the same, then we just return the sum. That's perfectly fine. Now, if a and b are the same, then we return 2 times their sum. Well, why do we go ahead and return 4 times a? Well, if I know a is equal to b, then I don't need to do a times 2 plus b times 2. I can just go ahead and return a times 4. Right. So that's kind of what's going on here. Hopefully that cleared up any confusion. So yeah. Um, all right. So if anyone has any questions, go ahead and ask them now. I do not have anything else. So if you guys have nothing, then I guess we'll see you guys next week. Um, so yeah. Again, if you have any questions, feel free to ask them. If you can't think of any right now and you have one later, just email us at capitalroboticsclub.com or at gmail.com. And yeah, uh, thank you so much for watching. And I guess see you next week if you don't have questions. Alright, it looks like no one has any questions. So thank you for watching, and we will see you guys next week.